The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Young Engineers of Today and Amazing Mechatronics. So we're going to continue with Arduino like we do, and if I remember correctly, we finished off our blinking LED. So we did the software, we did the circuit for it, we did all that good stuff. Our next one, our next project is going to be to upgrade to multiple LEDs, which is actually kind of more interesting than it sounds. But before we do that, I'm going to spend a little bit of time just doing a little bit of review, since it's been a weekend since we touched any of this stuff in a classroom capacity. I don't know what you guys did at home, but it's been a minute. So an Arduino, I'm going to go back in time a little bit for this. An Arduino is a microcontroller. That is to say, it's a really small version of the computers that factories use to control all their machines. It's also a much more simplified version, kind of by virtue of the fact that it's much smaller. Although there are factories out there that are technically run by Arduinos. Just you don't necessarily want them to be building your stuff. It can depend. Regardless, Arduinos are good for that kind of a thing. Arduinos can also do a whole lot of other stuff. You can use them for quadcopters, you can use them for random in-home projects, you can use them for basically whatever. Their main draw is that they're cheap and they're programmable and they're compatible with really like any small electronics, and the applications for them are varied and seemingly endless. An Arduino is sort of the translator, so to speak, between circuits and physical objects and code and software objects. That's not a 100% correct assessment of what an Arduino can do, but it does do the blending between the two very nicely. That is to say, you can create a circuit that does something cool, as circuits tend to do, and you can create a program that controls that circuit and does something cool, as programs tend to do, and the two of them together end up making a really cool object. Our first Arduino project was very simple, and on its face, probably didn't seem that cool, although maybe you guys thought it was kind of neat to make that stuff, hopefully. But it is a good example of how an Arduino can sort of marry the two concepts, circuits and programming, because what we ended up making was a very, very simple circuit. It was just simply an LED and a resistor hooked up to power. And that is it. And that should keep the LED up and running all the time, forever and ever and ever. As long as the LED has power, it stays on. Now, what the software ended up doing is it ended up cycling the power on that. It ended up telling it to turn on for a second, then stay off for a second, then turn on for a second, then stay off for a second. So by adding that little programming bit into it, we actually made our circuit have more capability than we would have otherwise. We increased its, I don't want to say complexity, although we kind of did, but that's not really the purpose. What we did is we increased its usefulness, I suppose. Now you might say it's not really useful to have a blinking LED. It's not also necessarily useful to have a solid LED either. And if we can make an LED blink, we can also make an LED turn on when we want it to. And that could mean it turns on whenever it receives a certain signal, or it turns on when a part of the code reaches a certain point, or maybe you expand upon the circuit and it turns on whenever a button is pressed. Stuff like that, which you could do with a regular circuit, but you could also change it to do something based on how the button is pressed and stuff like that. Anyway, I'm getting away from myself. Point being, an Arduino was meant to be programming and circuitry. So we had the very simple circuit and we had the very simple program, and the two of them put together had the result of being a slightly less simple project. Now what we're going to do is we're going to expand upon those ideas, and we're going to add more LEDs. Oh, look at this review. These green objects are called LEDs. We already knew about that. However, it is important to remember that LEDs have two legs on them. One is longer than the other. That's because LEDs have a polarity to them. That is to say, there is a right and a wrong way to plug in an LED. You could potentially plug it in backwards to your circuit. And that could mean that your circuit doesn't run, and you go, why isn't my circuit working? Until you flip the LED around and it's running properly. Then we've got resistors. Resistors reduce the current and the voltage, and they turn it to heat energy. And we do this because otherwise, if we sent too much power through to an LED could pop. And, it's cool to do once, but it's not something I recommend doing. And it gets a little expensive if you do it to every single LED that you plug into a circuit. So a resistor ensures that sort of thing doesn't happen. Resistors also are non-polar. They don't have a polarity. They don't care which way you plug them in. Resistors are really easy to work with. You just plug in a resistor where it's supposed to go, and it's good to go. But you don't have to make sure that maybe I plugged them backwards like you could an LED. An LED you can plug in backwards, a resistor you can't. All right. Yes, let's touch upon this real quick. So, no. Well, it's not here. Anyway, as far as the programming is concerned, we touched on variables. We touched on the void setup and void loop parts of the program, which always need to be there. That is to say, void setup and void loop always need to be there, at least at one point in the program, because the way they work is void setup sets up everything for the program, and void loop then takes over afterwards and runs over and over and over and over and over again as long as the Arduino has power. So the Arduino is going to be looking for those two functions, they're generally called functions, when you're uploading a new program to it. So you want to make sure that both of those are in there and both of those are used, because that's how you're also going to make sure that those programs run on the Arduino, is by putting code into there. But we'll touch more on that when we get to the second program. I'm going to try and devote more of a class to the second program. If we can get to it today, that'd be awesome. If not, that's okay. But at least just walking through why we do certain things. So we already did making an LED blink. Now we're going to make 8 LEDs blink. We're going to skip right over 2, because 2 was the same thing. As 1, it's the same thing as 8. Well, almost. 8 LEDs, we're going to introduce a new concept that's going to make it easier to work with 8 LEDs. But if you can do 1, you can do 2. So why don't we touch on 8 and do some new stuff? So yeah, adding multiple LEDs involves a few advanced programming techniques. You may want to continue to lesson 4 and come back later to finish this lesson when you're more comfortable with Arduinos. That is not the case. There is actually a fair amount of stuff to be introduced in this, but it builds nicely upon what we went in the last lesson. So there's no reason not to do it. So let's get started. Let's hook up our multiple LED circuit so that we can do all kinds of neat things with multiple LEDs. As you can see, it looks a little bit more complex, but it's still not too bad. Let's walk through this. All right, so I'm going to go back over to Tinkercad so that I can do this. If you're working with Tinkercad, fantastic. If not, pull out your Arduinos so that you can work alongside your breadboards and your hey. Um, anyway, I'm gonna give everybody just like maybe 2 minutes to get everything that they need. Um, Tinkercad's super easy. I'm just gonna click on circuits and I'm gonna click on create new circuit, and I'm gonna go. I have to get logged in first, but you should already be logged in if you logged into Tinkercad last time around. Go away. I know how to start. All right, so yeah, I'm gonna give it until about 8:16, 8:17, and then at that point we'll continue the lesson in earnest. Okay, everybody should have everything up by now. So let's go ahead and get started. If you don't sweat it. Um, I'm gonna spend some time getting the setup done anyway, so you'll be able to still follow along there. So what we need are 8 LEDs. I'm just gonna drag 8 of them out. 2, 3, 4, 5, 6, 7, 8. We're going to need 8 resistors. If we check this diagram, we're also going to need 8 resistors. So 1, 2, 3. Oh, wait, hold on. Rather than do this, I'm going to make my life easier. If you're using Tinkercad, you can do this as well. I'm going to click on the resistor in order to bring it up. And we want it to be a 330 ohm resistor. So I'm going to go ahead and select that value. And then I can Control C and Control V it and just paste it. The advantage being that I only have to set the resistance once if I'm using 123D circuits. If you're using regular resistors, you don't have to set the resistance at all. You just have to grab the right ones. So it's kind of a moot point. But for 123D circuits, yeah, go ahead and put all that there. And that is good to go. So we've got 8 LEDs, we got 8 resistors, but of course we cannot forget the most important things. A breadboard and our Arduino Uno R3, which is functionally identical to your breadboard. I'm going to click on it and rotate it with the R key. Again, if you're using an Arduino at home, you can grab it with your fingers and turn your hand. You don't have to follow my explanation, but you know. Alrighty. Now we begin the somewhat tedious process of organizing all of these things, because Of course. Rotate, rotate. Rotate, rotate. There we go. Actually, we need to rotate everything, all these LEDs 90 degrees. And the reason why I need to rotate all these LEDs 90 degrees, as a reminder, is because any electrical component we plug into a breadboard needs to go between buses, which are these horizontal things in the middle and the vertical ones on the sides. Buses are just parts of the breadboard that create a circuit. We want to make sure that we're moving from, we're moving from one circuit to another on the breadboard. We don't want to keep it on the same circuit because that's how a short circuit happens. And again, that's how you get fire. All right, so we got our 8 LEDs, we got our 8 resistors. Let's go ahead and start plugging them in. As you can see in our diagram here, it looks like our LEDs are just, so we've got them hooked up, and then the plus side is hooked up to the power, and the minus side is hooked up to the resistor. So the plus side, if you'll remember, is labeled the cathode. So if I check it out up here, wait, no, the plus side is labeled the anode. Good Lord. Yeah, the plus side is labeled the anode. So we check it out. All right, so we've got an anode and a cathode. We go ahead and plug each of these in sequence. Now I'm going to do this bit for funsies because I am running 123D circuit. First, I'm going to move these back because I want to give myself ample space to plug the resistors in. There we go. That should give us plenty of space to get the resistors plugged in. And actually, yep, we want to plug it in there. So we want to plug the resistors into the cathode, or the shorter leg of the LED. And then we want to plug some power into the anode. However, what I'm going to do is I'm going to set up a common ground first. Now, the ground is because we need to complete the circuit. By doing so, we will have a full circuit from beginning to end, and everything will operate as it should. I'm going to make this black because, you know, the sort of the more common way of denoting what's ground for smaller circuits. And then I'm going to take, let's see here. I believe they use every pin from 2 to 9. So let's go ahead and do that. So 2, 3, 4, 5, 6, 7, 8, and 9. All right. Once you get everything plugged in like this, go ahead and raise your hand. In the meantime, I'm going to do something just not strictly necessary, but a little bit of dopey fun. Alrighty, we got a couple of hands up so far. A few more hands are up. I'm going to wait for us to get at least about 75% hands up before I move on. Okay, looks like we've got about enough hands to justify doing this. So let me go ahead and get the Arduino programming thing, interface, IDE, editor, whatever. I can't. Words and I are having a disagreement today. So it'll be just a moment while that gets started up. Okay, there we go. Now again, as a reminder, here's our void setup and our void loop. We have to make sure these are in here, otherwise our program doesn't really run very well. In fact, it won't run at all. It'll yell at us, say that everything's all wrong, and that we need to fix everything. So we try to avoid the Arduino yelling at us because it uses mean words and it makes me feel very sad. Anyway, so here's the deal. Remember the when we did the first one, we did this whole bit right here where we created a variable of integer type called LED pin and we set it equal to 13. We're going to do a similar thing here because we're going to do this program the hard way first. And then we're going to do this program the coder way, which is the easy way or the lazy way or however you want to think about it. So let's do this all the hard way first. In a sense, conceptually, it's very easy. LED pin 1 is equal to 2. That's because our first LED pin is hooked up to pin 2. Then we're going to have INT LED pin 2 is equal to 3, and INT LED pin 3 is equal to 4, and so on and so forth. Because again, we've got one LED pin hooked up to pin 2, then the next one's hooked up to pin 3, then the next one is hooked up to pin 4, then the next one is hooked up to pin 5. So we could do this for as much as we need to. So let's say 4, 5, 6, 7, 8. And we had 8 pins, so we don't need any more. And then we can say it's 5, 6, 7, 8, 9. So as you can see, what I did is I set up a whole little sort of collection of variables here. I've got LED pin 1, which is 2, and then 2 for 3, 3 for 4, 4 for 5, 5 for 6, 6 for 7, 7 for 8, and 8 for 9. Just like what we got here. So 9 is hooked up to the 8th LED. So 8 separate variables holding on to 8 separate values, representing 8 separate LEDs. Cool. It's easy. Now what? Well, now we've got to initialize those LEDs, right? We've got to make sure that they're all set up as output LEDs. So that's pin mode. And then in here, we need to feed in which pin it is, and then whether or not it's going to be an input or an output, and all these are going to be outputs. So in the interest of saving myself a little bit of effort, I'm going to copy and paste this. And it's not going to copy and paste cleanly because this is the story of my life. All right, let's see what we got here. Delete and delete. So 1, 2, 3, 4, 5, 6, 7, 8. And then we just replace these all with the different LED pins. All right, we all following so far? We created 8 separate LED pin variables. They all point to 8 separate pins, which control 8 separate LEDs. We then set up all of these LED pin variables, by extension, the pin slots these pins are plugged into, to be outputs. So now we've got 8 separate outputs hooked up to 8 separate LEDs. Next, we need to turn each one of these on and then off in turn. So the easiest way to copy paste this is going to be digital writes. Because remember, digital writes is how we send an electrical signal out on these digital pins. Notice they're labeled digital. It's going to be an output, so it's going to be digital write. If it were an input on these pins, it would be a digital read. If it were an output on the analog pins, it would be an analog write. If it were an input on the analog pins, it would be an analog read, which is something that you guys will be messing a lot around with later on. But as it stands right now, we want to send information out of the digital pins, so we are using a digital write. So digital write LED pin 1, because we need to tell it which pin, and we need to say whether or not it's going to be on or off, high or low. In this case, it's going to be a high, so boom, done. Then we're going to delay for a second, and I'm going to type things correctly, and then we are going to digital write LED pin 1 low. So now we're turning the LED pin off, and then we're going to delay 1 second. Now, this is nothing new, right? You saw this in the first program. We turned on a pin, we waited a second, we turned off the pin, we waited a second. And then the program kept looping from there. However, we've got 8 pins that we're going to do this to, so we're not going to stop there. We're going to copy paste a cue air horn. 2, 3, 4, 5, 6, 7, and 8. And then, like the mediocre copy paster I am, I'm going to change the value in each of these to the respective LED pin. And I messed up. Like I said, I'm mediocre copy pasting. There we go. 4, 5, 6, 7, 8, and 8. All right. So this is going to be our final program. This is pretty easy to follow. This is exactly the same program, but we do it again 7 more times. So this is literally the exact same program as the first one. It's just 7 times longer, 8 times as long. Let's say that. That works, right? Like literally, insofar, well, almost literally, not quite literally. It's very close to 8 times as long as far as lines of code are concerned. Things like void setup and void loop kind of throw off the final numbers, so it's a little bit less than 8 times as long. But whatever. Anyway, the important thing is here. This is nothing you haven't seen before. This is everything repeated, but just more of it. And yet I said this was the incorrect way to do things. Why is that? Let's go ahead and throw it in there. I'm going to copy it and then paste it into my code editor here, and we should see paste. That's hello. Copy. Paste. Oh my God, do you not support copy paste? Okay, there we go. That's what it is. I had to close the blocks editor. I've never actually worked with the Tinkercad one before. All right. So we've all our T's are crossed and our I's are dotted. Let's upload and run and see what happens. Why is this a problem? All right, that one turns on, and 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 that one turns on. And 16 exhaustive seconds later, we've gone through a loop. Exhausting, I guess, seconds later. So what exactly is wrong with this? Why is this bad? We could fiddle around with the order of things so that we could have them all turn on and then turn off in sequence instead of turn on, off, on, off, on, off, on, off, on, off, and so on. We can have them, work inwards and then outwards. We could do all sorts of things. This, for all intents and purposes, is entirely functioning code. So what's wrong with it? Well, what's wrong with it is it's way too much effort. Look at how much code we had to type. Jeez. There are far easier ways to do this. And in order to get you introduced to these far easier ways to do this, there are multiple ways to do it that are easier, but I'm going to introduce you to one very straightforward way that is easier. I'm going to have to introduce you to a couple of new concepts. And we're going to definitely cover one of them today. We're probably going to cover the next one on Thursday. So you're going to have partially completed code just in time for the end of class today. Isn't that exciting? That's amazing. All right, so here's the deal, yo. I can't believe I just said that. First off, we got a lot of variables. We got a lot of variables that are very similarly named, that reference similar things, and that are in a sequence. Surely there must be a better way to do this. Well, I'm here to tell you that there is. Imagine, if you will, that a variable is like a box. It's a box, and it's not like a cardboard box, but it's sort of like a cubby hole you've got in the wall. And you can place things in there. You can place in, I don't know, food. Here's a loaf of bread. Why there's a loaf of bread in there, I have no idea. You could place in there a cat. that inexplicably has a mustache. You could place in there uh, a baseball bat. Keep in mind, none of this stuff is to scale. That looks like a stalk of celery. You could place in there a car, and the cat is now also a car. So this analogy is not exactly correct because the way variables work is if I wanted to fill this cubbyhole with bread, well, bread is a type of food. So I could really only fill it with other types of food. I could put apples in here. Look at that apple. Man, that is an apple drawn by an artistic genius. I could put an entire pizza in here. Which looks like a bicycle wheel. I could put in, I don't know, a pot of pasta. Apparently, I've got carbs on the mind. I could put in different types of food, but I could not throw a car in there because people don't tend to eat cars. A car is not a food. Um, Variables work similarly. Notice at the beginning of this, I say that this LED pin variable is of type int. That is to say, it is of type integer. It can only ever hold whole numbers. Now it can hold 1, 2, 3, 4, 5, a billion. Doesn't matter. Kind of does, but we'll get into that later. Um, but it doesn't matter. As long as it's a whole number, the program is okay with it. Now, I could try and throw in the letter B, but it's not going to like that. It's going to say, you can't, no, don't, what do you, go away. And then we're going to be sad because it was mean to us. But if we say that the cubbyhole, in this case the variable, is going to hold something, it can only hold that type of thing. Now, if we wanted to, we could say that this cubbyhole was only going to hold pets. So now we've got our cat, we got our bread, except it's a dog. Look at that dog. Um, we could have, you know, an elephant. Some people keep elephants as pets. You know, stuff like that. So it can only hold what we tell it to. To go back, if it can only hold strings, it can only hold letters then. If it can only hold Boolean values, it can only hold true or false. However, now we can have a bunch of these cubby holes in the wall, and that's all well and good. Now, imagine we had a grid of cubby holes. And we said, okay, since cubby holes can only hold one type of food at a time, let's say we've got this whole grid of cubby holes and they can all hold their own food. So we've got bread in one of them, we've got apples in another, or an apple in another, we've got a bowl of soup in the next, we've got a chicken in the next one. You know, it goes on and on. We've got all these linked together things that have food in them. We label it food. And this is going to be food 1, food 2, food 3, food 4, food 5, food 6. So we can say, hey, what's in food 3? And we can go, oh, it's soup. Or what's in food 2? Oh, it's an apple. Or what's in food 5? Nothing. Or what's in food one? Uh, some bread that's really seen better days. So now we've got a whole sort of collection of these things that are all related together, and we can reference it by name and number. We can say, what's the third thing in food? We can do a similar thing here with all of these. And this concept is called an array. So instead of saying LED pin 1, 2, 3, 4, 5, 6, 7, and 8, we can say integer LED pins, give it some brackets, and set it equal to a certain amount of values. So we can say 2, 3, 4, 5, 6, 7, 8, and 9. Close that out. So what we've done is we've just created 8 variables that are all sort of glommed together, and we can reference them whenever we need to. So now, if we wanted to reference LED pin 1 here, instead we'd say LED pins and then a slot. So if we wanted to access the first one, we'd actually say 0. What, you might be saying? That's weird. That's because computers start counting at 0. So you'll find some very opinionated people on the matter. Some people believe that computers should start counting at 1 when it comes to stuff like this. Some people find that it really isn't that big of a deal. Some people feel like it makes sense. Some people feel like it fits better with the way a computer program flows. It's all entirely sort of subjective, the opinions on the matter. The reality is the vast majority of the programming languages that exist out there start counting at 0. So if we ever want to reference the first thing in an array, we're going to reference the 0 element. Now, why might that be? Or why is that, you might be asking? Well, there's a semi-apocryphal story, that is to say that it may or may not be true, that basically deals with the fact that way back in the day when computers had memory measured in bytes as opposed to gigabytes, and, you know, they were the size of rooms, and there was a primitive terminal, and, you know, all this different stuff. Kilobytes, I think, came with the advent of terminals. Anyway, one particularly frugal programmer was looking at all of his programs and going, hey, man, I could save space by starting at 0 instead of 1. And it would work better with the program flow too, because there's a whole number there that we aren't using. And then he put it into his programming language, and the rest, as they say, is history. Now, this may or may not be true. I have not looked it up on Snopes myself. I believe I did at some point, but I don't remember. I'll just be honest with you. I don't really remember, and I don't want to say it's true and then be wrong. Anyway, point being, anytime you're referencing an array, you start at 0. So now, LED pin 0, we go, what's here? Well, let's check out LED pins. All right, the first element is 2. Perfect. So this is the same thing as 2. LED pins. The next element is 1, then 2, whoops, then 3, then 4, then 5, then 6, then 7. And you might be looking at this going, wait a minute, we didn't really save any time at all. And you'd be right, because so far, we haven't really leveraged the capability of arrays. This is okay. I mean, we saved 7 lines of code up here, but this down here, we hardly did anything. We just did the same thing, but now we got to type using the square brackets, and that's just a pain. Come on, man. So this ties directly into the second concept that will make programming this particular sketch a lot easier. That we're going to touch on Thursday because I do not have any time at all to really start talking about that stuff at all. So that's going to do it for today. I realize that this sort of leaves arrays at a question mark. Why would you use them? What's the purpose of them? Stuff like that. That's okay. We're going to get there. Hopefully, it'll all make sense on Thursday to you guys. I'm going to go ahead and do the poll questions. If you have any questions about anything, feel free to hang around after the poll questions are done and throw them my way. Otherwise, you're more than welcome to head out after the poll questions are done and have a wonderful couple of days, and we'll see you on Thursday.